Okay, so again, we're going to go over 4.5 and 4.6. So this is 4.5 notes solving related rates. And remember, we did the very first equation yesterday, but I'm going to go ahead and go through it again. Okay. So it says if y squared equals 3x to the fourth plus 6x, find dy dt when x is equal to 1 and dx dt is equal to 2. So our first thing that we have to do is take the derivative respect to time. So this would be 2y, thank you, dy dt is equal to 12x cubed dx dt plus 6 dx dt. Okay. We took the derivative of every single term and made sure we included some variation of d dt, depending on the variable. Okay. Then we know that x is equal to 1 and dx dt is equal to 2. So I'm going to plug in those values. So 2y dy dt is equal to 12 times 1 cubed times 2 plus 6 times 2. Okay. So then from here we get 2y dy dt is equal to 24 plus 12, which is 36. Then getting dy dt by itself, we're going to have to divide both sides by 2y. So dy dt is equal to 36 divided by 2y, which simplifies to 18 over y. Okay. So now we got to go back and find what our y value is from our original equation. Okay, in our original equation, we know that x is what? 1. So I'm going to plug in 1 for x and solve for y. So I have y squared is equal to 3 times 1 to the fourth plus 6 times 1. Okay. So this is y squared is equal to 9. Which means y is equal plus or minus 3. Okay. So then plugging in those values for y into dy dt, that tells us that dy dt equals 18 divided by 3 or 18 divided by negative 3. Which means dy dt is equal to plus or minus 6. And that's our answer. Okay. Any questions on 1? Okay. Then it says guidelines to solving related rate problems. So this is just basic steps. Let's say you're stuck and you're not sure where to start. When you're given these word problems, the first thing I would do is I would draw a picture. So whatever it's talking about, draw that diagram. Make a list of all known and unknown rates. So if they give you what dy dt is, make sure you write that value down. Relate the variables in an equation. So if they don't give you an equation, create that equation. Okay, take the derivative respect to time, and then substitute in your known values to solve. Okay. So First example, it says the width of a rectangle is increasing at a rate of 2 centimeters per second and its length is increasing at a rate of 3 centimeters per second. At what rate is the area of the rectangle increasing when its width is 4 centimeters and its length is 5 centimeters? So first we draw a diagram. So it says that the width and length of a rectangle, okay, so here's my rectangle, okay. Here is length, here is width. It says the width is increasing at a rate of 2 centimeters per second, so increasing at that 2 centimeters, per second, and the length is increasing at a rate of 3 centimeters per second. And then it's asking about the area. Okay, so I set up my diagram. Okay, I know that the area of a rectangle is what? Length times width, so area is equal to length times width. Okay, so I set up my diagram, I wrote my equation, and now I'm going to derive my equation in respect to time. So that would be dA dt is equal to, and then we have the product rule, length times width. So I would take the derivative of length, so this would be dL dt times W plus L times the derivative respect to time for width. So that would be dW dt. And then in the next part of the problem, it tells me what all these values are. It tells me that the width is 4 centimeters and its length is 5 centimeters. And then it says that the increasing rate of the width and the increasing rate of the length. So it gives us all these values. So the values it gives us, and I'm going to write it out so I see it visually, is that length is equal to 5, width is equal to 4, and then width of increasing, so dW dt is equal to 2, and dL dt is equal to 3. So I got all of those values from the problem. So I'm going to use those values and plug them in to find dA dt. So I have dA dt is equal to 3 times 4 plus 5 times 2, okay, which means dA dt is equal to 12 plus 10, which is 22, and then what would be the units? Centimeters squared per second. Okay, so that would be the answer. 22 centimeters squared per second. Okay. So really, we wouldn't need to draw the diagram in something as simple as this. Okay? We all know what a rectangle looks like. We know where the length and the width is. So it's not something, unless they specifically say draw the diagram, that you would have to do to get points. Okay? Mainly you would have to do these processes where you first write the equation, derive it respect to time, plug in your values, and then make sure your answer includes the correct units. Any questions on this example? Okay, the next example we have is the triangle example. It says a police car approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. I feel like this problem was on the last one, but now we're going to have to solve it. So it says when the police car is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with a radar gun that the distance between them and the car is increasing 20 miles per hour. So if the police car is moving at 60 miles per hour at the instant of measurement, what is the speed of the car? So since we have a triangle shape, okay, we can label this. We can say this is X, this is Y, and this is Z. Or you could label it A, B, C, right, to signify that we're going to be using the Pythagorean theorem. Okay. So for Pythagorean theorem, we know that's x squared plus y squared equals z squared. Okay. So once we establish that, then we're taking the derivative respect to time. So we have 2x dx dt plus 2y dy dt is equal to 2z dz dt. Okay. And then the problem, they give us these values in order to plug in and solve. So off to the side, I'm going to write those values. So x is the car. What did it say the car was? 0.8. Okay. And then y is the police car. In the problem, they said 0.6. Okay. And then dy dt, which was the rate of the police car, negative 60. Good. And how do we know it is negative 60? He's getting closer, right? He's going towards it. So negative 60. Good. And then we have dz dt. We know it's dz because it says that in the problem, if the radar gun shows the distance between the police and the car is increasing at 20 miles per hour, so dz dt is equal to 20. Okay. So that means we're missing two values. We're missing z, okay, and we're missing dx dt, which I believe this is what we were ultimately trying to find. So since this is a triangle and we are given x and y, how could we find z? The Pythagorean theorem. Okay. So I'm going to go over here to my triangle. Okay, this is 0.6, this is 0.8. Okay, so in order to find z, I know I have to do 0.6 squared plus 0.8 squared is equal to z squared. Okay, so that's 0.36 plus 0.64 is equal to z squared. That is going to give us 1 equals to z squared, which means z is equal to 1. Okay. So with z equal to 1, we're now going to go back and we're going to plug in all those values so we're able to find dx dt. Okay, so we know right here that z is equal to 1. Okay, so we have 2 times 0.8 dx dt plus 2 times 0.6 times negative 60 is equal to 2 times 1 times 20. Plugged in all of our numbers that we found from the problem and the Pythagorean theorem originally. Everything's plugged in. Then we simplify. Okay, so we have 0.16 dx dt, 1.6, thank you. Okay, minus is when someone want to simplify that for me. 72 is equal to 40. Okay. So solving this out, we get dx dt is equal to what value? Say that one more time. 70. So when we add the 72 and divide by 1.6, we get 70? No, I'm just asking because I don't have the calculator. Yeah? Everyone agree? Agree? I'm not saying you're wrong. Okay, 70. Okay, and then what would be the units for this? Miles per hour. Perfect. So the speeding car is going 70 miles per hour.